Lecture number 11, Basic Concepts and Theoretical of Analytical Mechanics. In theoretical physics and mathematical physics, analytical mechanics or theoretical mechanics is a collection of closely related alternative formulations of classical mechanics. It was developed by many scientists and mathematical during the 18th century and onward after Newtonian mechanics. Since Newtonian mechanics considers vector quantities of motion, particularly acceleration, momenta, forces of the constitutions of the system, and alternative name for mechanics, governed by Newton's law and vectorical mechanics. By contrast, analytical mechanics use properties of motion representing as a full, usually its total kinetic energy and potential energy, not Newton's vectorial forces of individual particles. Analytical mechanics takes advantage of a system's constraints to solve problems. The basic concepts of analytical mechanics are Lagrangian mechanics and Hamiltonian mechanics, Rosian mechanics and Hamilton-Jacobi equations, and Appel's equation of motion, and Koopman von Neumann mechanics. And two dominant by boundaries of analytical mechanics are Lagrangian mechanics, using generalized coordinates and corresponding the generalizing velocity in configuration space, and Hamiltonian mechanics, using coordinates and corresponding momenta space. The methods of analytical mechanics applied to describe particles in which a finite number of the degrees of freedom. And the analytical mechanics is mathematical formulation of Newtonian mechanics. Its physical counting is the same as the mathematical structure, has interesting features, and formalism in mathematics through introduction by the 20th century German mathematician David Hilbert, which holds that mathematics can be reduced to rules for manipulating formulas without any reference to the meanings of the formulas.